Alrighty, so in this lab, we're going to be first taking apart a potentiometer, sometimes called a rheostat. It's just essentially a variable resistor. It's a resistor that can have varying resistances depending on how far you turn the knob. And so there I cut myself on it, trying to open it. This potentiometer is different than the one that we're going to be using when we make the circuit, but we just wanted to use one to get the idea of how it works or what it looks like on the inside. The goal was to put it back together and get to work, but that didn't quite work out for us. So what I did here to take this one apart is there's 3 tabs that hold the little canister underneath the potentiometer. I bent those tabs outwards to take it out, and there was nothing on the canister. The canister is just to protect what is underneath. So after a little bit of wrestling with it, well, I eventually get it. And there it goes. Came right off. And so there we can see that when you turn the knob, there's a disc that has serrations on it that line up to the edge. The serrations line up to the edge of the pins, or they line up to the pins, and the different amount of serrations and different amount of wire lengths you have there, the more or less resistance you'll have. Hence the term variable resistor or potentiometer. So now that we've taken it apart, we discard that one because it didn't go quite back together like we planned. So we grabbed a different one, a different potentiometer. I believe that potentiometer used in this experiment was hold on a moment. It was a 2 kilo ohm resistor potentiometer. It was a linear type, meaning it's not logarithmic. It's a linear change. There's no exponential change to it based on the knob turning. It's a linear change. So I'm gonna hook it up with these my favorite little clips in our 4 AA battery pack, 6 volt, and I'm gonna hook up the furthest left side of the potentiometer to the negative of the negative part of the 6 volt battery pack, or the black wire, and then I'm gonna hook up the middle part of the potentiometer, the middle pin, to the short, or the cathode, the LED, the short pin. Then I hook up the red wire, the positive of the battery pack, to the anode of the LED. The other pin can be disregarded for now. Well, not for it's just for other applications. That's all. Just to demonstrate the potentiometer, all we need is these 2 pins on it. When we connect it, now we were supposed to keep it all the way, the potentiometer turned all the way counterclockwise, but we kept it all the way clockwise, hence why the LED is so very bright. In fact, that LED was very close to burning out after this. We didn't properly start. We were supposed to have it turn the other way, but we didn't, so that's why it's so bright. But you can see as I turn it clockwise, the LED gets dimmer and dimmer and dimmer. Just like we saw in the other lab when we put resistors of higher resistance in, the LED got dimmer. This is just a variable. You don't have to swap it out. Very useful in dimmer switches in our houses, and that's potentiometers.